Today I want to talk about building a SaaS and how not all approaches are created equal. So, when you first started building applications, you were probably taught to build it in a layered approach where you start your application with a database. You start modeling your data. Maybe it's in a SQL database where it's relational, maybe it's in a document database like MongoDB. And then after you get your data schema set up, you start with some kind of compute layer. This is where you're going to be calling the data, you're going to be adding your business logic, and you might do this in multiple approaches. Maybe it's an MVC pattern, but the point is you're going to add the actual source code that runs on the server. And nowadays, with a modern application, you probably have some kind of web app on top of that as well, where you've decoupled the UI from your back end. So this might be a React application calling REST APIs in your compute layer. So you built this application and it works great. You're like, this application is exactly what people need. How can I offer it to others? How can I make sure that other people can use it? One option is, throw the code out there and let everyone set up their own instance of that application. They can host it themselves wherever they want to host it, and they can run, manage, and update it themselves. But the idea of a SaaS, or software as a service, is that someone's going to sign up and you're going to run it for them so that they don't have to worry about it. They get a username and password, they get access to the application, and they don't have to think about things like updating it, patching it, how big does their server need to be, what software do they need to install, etc. It's just all done out of the box. And you can think about classic SaaS offerings on the consumer side, things like Gmail, where no one thinks about the application of Gmail. They just go to gmail.com, log in, and use their email. It's seamless and it just works. So the first approach to taking this classic application design and turning it into a SaaS is to simply make multiple copies. So rather than just having the one for yourself, you go ahead and create new ones for each customer you bring on. And in a SaaS world, these are called your tenants. And you create new infrastructure for each tenant in this approach. And that's called the silo approach. And there are a lot of benefits to doing this silo approach to SaaS. So you get to reuse the application you already built. You don't have to make many changes to it. Instead, you're just layering on a bunch of extra stuff to manage all the different tenants, to keep track of them, to deploy updates across all your tenants. So rather than modifying the application you have, you reuse it, and you're just adding on all of the maintenance tasks on top, layer it above the application. It uses all the existing developer skills you've worked up. You build an application of this the same way you've always built an application. And if your customers are small, there's less concern over scale. They're not likely to outgrow this basic model. So you just need to spin up one database, one virtual server or container, and one web app, and you don't have to worry about scaling or sharding the database or anything else, because each customer gets their own database, and the chance that one customer outgrows it is relatively small until you start working with extremely large enterprise scale customers. So the drawbacks to this siloed approach: you need to write more code to manage all of these tenants. So you spend a lot of time writing code, not for your customers or for your application, but instead you're writing code to run your SaaS. And there are some SaaS starter kits out there. I know AWS has a really good one that can help you with this management code, keeping track of the infrastructure, keeping track of the updates, but it is still more code. It's something more you have to maintain, keep track of, and run. You can certainly build it, but it is a very advanced update system, and it's something you need to think about. The other thing is now you're tracking and managing uptime for hundreds to maybe thousands of different applications. And it's hard to hit that, 3, 4, 5 nines for one application. Imagine doing it for hundreds to thousands. A lot of SaaS companies They can hide this away because they'll advertise their average uptime across all of the different silos. But if one customer is down for an entire month, they don't care that the uptime for the whole system was 99%. They were down for the month. They're angry about it. And I will say there's some significant drawbacks, but you can build a good business this way. You think about WordPress. WordPress is a single application, PHP, MySQL as the database. And when you buy WordPress on a SaaS, on the cloud, you're getting just that. You're getting your single instance of WordPress. And WordPress runs a lot of the websites out there. It runs a lot of the internet. So this can be an effective approach if this is the way you want to go about it. Let's talk about the next possible way to do it. And that's to rewrite the application so each user hits the same infrastructure. So we go back to one application. And now instead of everyone getting their own stack, their own instance, everyone's going to call that same instance. Okay? And this is called the pooled approach because all your tenants call the same hardware or virtual hardware. All of their resources are pulled within it across all of those tenants. And you have to rewrite the application to determine which tenant is calling the application based on some identifier. And then you have to isolate all of their data in the database according to that identifier. So again, think about Gmail. If I log into Gmail, it knows who I am and it knows to show me my email. It doesn't mean I have to have my own database. It doesn't mean I have to have my own domain name or email server. I just log in. It says, hey, I know who you are. Now I can go access your specific data and show you your specific settings. So the pros to this, one application to track and keep up and work on. You're not working on any extra stuff for maintenance. You're focusing on adding value for your customers. You have the ability to make and apply changes quickly because you are applying the changes to one stack rather than to hundreds. Cons here, you need to know that you're building a multi-tenant SaaS in the beginning of development. So you can't just start with a basic application and then later offer it up as a SaaS. And that's fine if that's not what you're building, but if you started with a traditional approach, you now have to do some rewrites. And that's why a lot of older software takes that siloed approach, while it's only the newcomers that have ambitious plans that, take this pooled approach to SaaS. And the other con is you now have multiple users hitting the same infrastructure. So you're immediately going to be thinking about things like scaling. On the database side, you're probably immediately going to be doing some type of sharding because having multiple users hit a single database, not a great thing. But one approach to improving that performance side to help with scaling is to take advantage of microservices. And here, instead of one compute instance and one database, we're going to set up a bunch of little services that handle distinct business requirements. And this is exactly how Elastic Commerce Cloud was built. So you'd have a microservice, to handle each endpoint. So you'd have one for products and one for cart, etc. And then the microservices themselves are going to have their own databases because, again, having microservices share a database is an anti-pattern. So we want to make sure that they each get their own data store. And in this way, each one can be deployed by themselves. All of the services can be scaled up and down individually. They can be updated individually, and you can have distinct teams working on each business unit. So not only as your infrastructure needs grow, but also as your employee base grows, it's easier to have programmers working together in these smaller teams rather than constantly stepping on each other with one giant application. All right, so now we have these two approaches. We've got the silo approach, where you're doing a separate instance for each one, and a pooled approach, where everyone's connecting to the same instance, and they're each getting separate tenants. Their data is isolated, but they are each connecting to the same infrastructure. And with the pooled approach, if you go for a very modern, forward-looking view like Commerce Cloud did, you're probably building it on microservices. You're hosting it on Kubernetes. You're integrating things like auto scaling. and you're able to handle anything from small companies to large. In choosing, I will say that the pooled approach is currently the gold standard for SaaS. So if you're building a SaaS, perhaps it does make sense to go with that silo approach. Maybe you already built the software and now you're just looking to offer it up. That would be a great place to start. And then you can start migrating to the pooled approach later. For instance, maybe you start with a siloed approach and then you combine those compute clusters into microservices, but each customer still gets their own database. Not ideal, comes with shortcomings, but it's a good intermediary step as you push towards that pooled SaaS approach. And I mentioned that it's the gold standard. And that's why companies like Stripe, Twilio, Elastic Path, and all the others are using this pooled model. This is what allows these type of companies to work with small indie developers that's calling the API 1, 2, 3 times a month, up to massive Fortune 100 companies that are just pummeling the system with traffic. And the system just auto scales and it's set up to handle this type of load. It's ready to go. Whereas with the siloed approach, very different story because each person has their own instance. So either you set up the infrastructure for a small company, so you keep your monthly costs low, or you set it up with a big company in mind and then you have a high monthly cost, but you can't do both. So while building, you can choose either one, but when buying a SaaS, I would definitely be looking to make sure any company you're working with takes that pooled model. And I know companies aren't forthcoming. They don't always want to explain how their architecture works. And both models are a multi-tenant SaaS. So they might just, hey, I'm a multi-tenant SaaS, don't worry about it. So some questions you can ask to figure it out. Will I get a dedicated instance? First question I'd ask. If the answer is yes, you're in that siloed approach. Will my data be isolated in its own database? A lot of times they will brag about this, thinking it's some kind of positive that your data goes into its own database. Of course, that means that you have your own issue here, your own point of failure. Do I need to contact you if I plan to have a big spike in traffic? With a pooled approach, there's so much excess capacity there. There's so much auto scaling in place that your big spike, even a 10x, 50x spike, is going to look like a blip. But if you're in that siloed approach and you even double your traffic, it's quite possible you're going to get 500 errors and your system's going to go down. And then what type of rate limiting is there? So if they say there's no rate limiting at all, you're definitely on the siloed approach. That's basically them saying, hey, hit the application as much as you want and it'll just fail when you've hit it too much. That's basically all it is. Just go nuts and it'll fail and it'll only affect you when it fails. So we're not worried about it. We don't need to know what the limits are. Whereas people with a pooled approach, absolutely they're going to give you rate limits because they need to understand what their customers are doing. And if they have a bad actor, if they have someone come in and try and just pummel the system to impact the overall thing, they need to know about it and shut it down before it causes issues. So they understand what's possible and they understand the rate limits, and they're going to be very transparent about those with a pooled approach. I've talked about how to identify it, and I've talked about some of these benefits, but I just want to reiterate the benefits of going with this pooled SaaS model. So the first is scaling. Cloud systems can auto scale, but auto scaling is not instantaneous. It can take a few seconds, maybe even a minute, as additional capacity is provisioned. You can't just turn it on in microseconds. If you're in that siloed approach, a viral event can still cause 500 errors. And maybe they'll over provision you, but it's never enough. You got to worry about scaling with that silo model because limits can be reached. But with a pooled model, a single tenant can have that viral moment and it's just a small bump on the overall system because it's going to be over provisioned, but it's going to be over provisioned for the entire thing, which means you have a lot of excess capacity to take advantage of. You've got a lot sitting in reserve, waiting to go to be called and be used as you're waiting for that auto scaling to kick in, which again might take a few seconds, maybe even up to a minute. Higher agility. That pooled model, as I mentioned, it creates a lot of efficiencies. You don't have to manage all of these instances. So centralizing and standardizing the experience is foundational for SaaS providers to easily manage and apply changes to all the tenants without having to worry about one-off tasks or one-off scaling or tenant by tenant update cycle or changes or patches that may need to be applied. So you're getting a lot of agility, you're getting a lot of time saving by modeling your SaaS in this way. And then you can take that time saving and you can put it towards innovation. So instead of spending all your time on maintenance and uptime, you get to actually build cool features that make your product better, that make your software better. So yeah, you get to innovate at a much faster pace. And the more you move away from that distributed management and the massive complexity of all these instances, the more you're free to focus on features. Next up is high availability. So you can have high availability on both models. But I will say a pooled model necessitates horizontal scaling up front. You can't wait as long with things like database sharding, with things like containerization and redundancy. You have to do that early on since your application gets really big really fast. Whereas on the siloed approach, you can get away with a single database, a single VM per tenant. And if there's an issue or downtime, that downtime is specific to that one user as opposed to everyone, which is why the people that offer this often hide their downtime in average stats. So if you are going to buy someone with that siloed approach, make sure you ask, what will my uptake guarantee be? Not the entire system, but mine specifically. If my specific database has an issue, when are you going to get it back online? How much downtime can I see? Next one, enhanced performance. When you think about a siloed approach, any type of tweaking and performance enhancements probably happen one tenant at a time, or maybe you roll it out to all of them, but you're not going to get a clear vision of all of the traffic going through. Whereas with a pooled model, you look at your logs and you see everyone's traffic all at once. You see all of the slow queries, you see all of the performance pinch points that happen across the system. And that can get you better analytics and better insight into how to make your system faster. And that's why, when you download your own software, run it yourself, or go with that siloed SaaS, they don't give you many performance guarantees. You'll get an SLA for uptime, but they're not going to make any big claims. Maybe they'll talk about previous load tests or other customers, but that's about it. But Elastic Path Commerce Cloud on that pooled model can actually offer a 100 millisecond guarantee, showing that performance can be guaranteed and you don't have to worry about it. And the last thing is cost efficiency. With the silo, if you're over provisioning for each instance, you have instances that don't get much traffic. You end up having to charge customers a lot of money on a monthly fee to cover those costs. And that extra provisioning doesn't even help with viral moments. It's just a side effect of the model that was chosen and having all of these different applications running. You also have to choose every layer of that stack for the database, compute, etc. Are you going to go for really cheap infrastructure and try and keep costs down so that your monthly cost is as low as possible? Or are you going to go for enterprise grade infrastructure and know that your monthly cost is going to be extremely high? Whereas with the pooled approach, because everyone's sharing the infrastructure, the costs can be based on usage. And that's often how it works, is they're going to ask you some stats about how you're going to use the software to determine the pricing. That allows you to do everything from working with tiny little, indie developers all the way up to massive enterprise customers and everything in between. And that flexibility comes from this SaaS model. I hope we've explained that not every SaaS is created equal. And there's pros and cons when you're building it and choosing which direction you're going to go in. If you were starting a greenfield project, definitely go with the pooled model. It's definitely the way to go. Unless you already have an application and you're trying to stand up a SaaS on it. Or maybe you know that the majority of your customers aren't going to use your SaaS, that the majority are going to buy the software to install themselves. Then maybe also you want to do that siloed approach because the majority of your revenue is coming from people building their own instance, so you don't have to worry about the SaaS the online component as much. Now, if you're buying a SaaS, if you're looking for a service, absolutely 100% go with that pooled model. Go with someone that's already implemented a very modern approach, something cloud native, something where you don't have to worry about scaling your own application. You don't have to think about downtime. You just get an application and you use it, kind of like Gmail or Twilio on the API side. When you call Stripe, you never think, hey, should I call up Stripe and let them know that Black Friday's coming? No. You just call the Stripe API and make your payments. Ideally, as we move to the API economy and a composable commerce world, your entire stack can look that way, where all of your SaaS companies work just as well, where you just call them and use them without a second thought. And if you have any thoughts on which SaaS model you think is easier to build, or perhaps what your favorite SaaS company is, someone that's really made impact on your development workflow, please go ahead and add them to the comments.